Hello everyone and welcome to TudloMathics. So, piecewise functions, and what are these functions? So, we need to start with the regular functions first. For example, f of x is equal to 2x minus 2. Now, for this function, this can be characterized as a regular function where we can find any value to be substituted into our variable x, and that outputs into a singular domain. So whatever variable that I can think of, or that whatever variable we can think of, the output of this entire function sits on this singular domain. Now, what distinguishes piecewise functions from our regular functions? Now, you need to understand that piecewise functions, any function with at least 2 points or 2 domains can be written as a piecewise function. So how do we write that? So here, for example, we take f of x is equal to open bracket. So this is another distinguishing characteristic of piecewise functions from regular functions. So for example, f of x is equal to 2x plus 1 if x is greater than 2 and x minus 2 if x is less than or equal to 2. Now, this is an example of a piecewise function because here we have a condition where we will use this formula 2x plus 1 if the variable or the value of x is greater than 2. And if our value of that variable is less than or equal to 2, then we will use this formula. So we have different formulas that depends on what the value is of our variable, and that is the very characteristic of piecewise functions, because piecewise functions can be defined by different formulas and not only a singular formula like our regular functions such as this, like that. We cannot only define the domains or the output of this function by a singular formula, but by multiple ones. So that is the very definition of piecewise functions. Now, we need to evaluate this. So for an example, we can have evaluating this piecewise function at f negative 1. Now, at f negative 1, we first need to look at the value of our variable, which is negative 1. So it is lesser than 2, right? It is lesser than 2 because it is a lesser value than 2. Negative 1, 0, 1, and 2. Negative 1 is lesser than 2. And because of that, we know that we will use this formula in evaluating this function. So copy all of that. F negative 1 is equal to, x minus 2, because we know that we will be using this formula, x minus 2, and we will just substitute that variable or that number. So negative 1 minus 2, and we need to remember when we are subtracting two negative numbers, we're just going to add them both and just copy the negative sign. So negative 3. So we know that f at negative 1 is equal to negative 3. And this is the value of the function at this specific variable. Now, another example. We're going to evaluate this function at f3. Now we know that 3, or the value of 3, is greater than 2. So what formula will we use? Exactly, this formula right here. So just copy everything. f3 is equal to, and copy that formula, 2x plus 1. And we're going to do exactly as our previous step that we did, where we need to substitute for the value of 3. So we need to take this into account. When we have two numbers, or we have a constant number like 2 and x, whenever we substitute any number here for this x, that is automatically multiplying to this number. So whenever you have like 2a or 3b, and that you will substitute any number for these variables that is automatically multiplied to that number. Okay? So in this case, we are going to be multiplying 2 to 3. And we add 1. So again, with our PEMDAS, we first need to multiply, or we first need to evaluate by multiplying. So we need to multiply 2 and 3, which is equal to 6. We add 1, which is equal to 7. And that is how we evaluate piecewise functions. Okay, so another example. Let us take f of x is equal to, open brackets, 2x minus 1 if x is greater than 0 but less than 2, and x plus 5 if x is greater than or equal to 2. Now, note that in this function, we have an inequalities, or an intervals, mind you. Sorry. We have an interval here where x is greater than 0 but less than 2. So we just need to follow the direction or the instructions that is needed here. So when answering this, let us evaluate this first at f at 1. So your value of 1, where does it land? Is it greater than or equal to 2? No. But 1 is less than 2 but also greater than 0. So with that in mind, we know that the formula that we will use is this, 2x minus 1. So we know when evaluating this function at f at 1, we'll be using this formula. So simply copy 2x minus 1, and again, when we are substituting, we multiply those terms and variables when they are side by side. 2 times 1, that is 2, and you subtract 1, that is equal to 1. Now, let us evaluate this function at f2. Now, f2, we know that 2 is equal to 2 here. So we know that the formula that we are going to be using is this formula, the second formula, x plus 5. So simply copy that, f2 is equal to x plus 5. And again, with our previous steps, we're just going to substitute. So 2, substitute 2 to x, plus 5 is equal to 7. So we know, in evaluating this function at 2, where the value of x is equal to 2, we know that the answer is 7. And another example, f at 0. Now, you need to take a step back into this and read or look at the formulas. So we know that the value of 0 is not inside this function, or is not defined by this function. Why? Because it is not greater than or equal to 0. So it is not this. But it is also not greater than 0 because the value is 0, right? And it is also not equal to 2. So this is also not the formula that we will be using. So what to do in these situations in which the value of your x is not defined by any formula in your piecewise functions? Then that simply means that that value, that x value, is simply undefined. Because in this piecewise function, or in this specific piecewise function, the value of 0 does not fall in the domains of this function. This is the domain. So it does not fall inside this. So whenever you have a value of x that cannot be defined by any of these formulas, the answer to that is simply this, undefined. So I hope that makes it clear to you in evaluating these kind of piecewise functions. Okay, so another example. I just need you to take a look at this first. F of x is equal to x plus 2, negative x, and x minus 1. If x is equal to 2, if x is greater than or equal to negative 1 but less than 0, and if x is 0 or greater than, x is greater than 0 but less than 2. Okay, so take a step back and look at this problem and evaluate this at these values. F of 2, where x is equal to 1, f is negative 1, x is negative 1, and f is 2. So take a look at these problems and we will solve this later. And just pause the video if you want to try it for yourself. So we know the value of 2 is defined in this formula here. So we know that we will use this formula, x plus 2, to solve this function. So just copy x plus 2 and just substitute 2 there. 2 plus 2, and we will have 5. So the value of this function at value of x, where the value of x is equal to 2, is equal to 5. Now, where the value of x is 1. So we know here, so let us find the value of x if it is defined in this function. So we know that it is not this, and it is also not this, because 1 is greater than 0, and it is not defined in this function, or in this formula, mind you. So that leaves us with this. 1 is less than 2, but it's also greater than 0. So we know for a fact that we will be using this formula for this value of x. So just copy x minus 1, substitute again our 1 minus 1, and that brings us to 0. Next, the value of x is negative 1. So where is negative 1 here? Here, where x can be greater than or equal to negative 1. And if that is the case, we will have a negative x here, value. So just copy it. So negative x. So do note that we are going to be substituting a negative number to a negative variable. So in making this easy, I want you all to just copy the negative sign first, negative sign, and insert it into a parenthesis. So substitute it first. And do note that when you have two negative signs here, that cancels out into a positive sign. So we will be leaving it with a 1 as our answer. And finally, our f of 2, which is already defined in our first example. So simply copy that, 5. And that is all for piecewise functions. I hope you all understood these kinds of functions a little bit more, and see you in the next video. Thank you.